In this video, we're going to be talking about the periodic table and the properties of some elements based on very large portions of that table. In future videos, we're actually going to, in another unit, talk about more of the predictive properties of elements based on where they are in the table and how you can make certain changes from one element to the next. So you are going to need your notes, you're going to need something to write with. I would probably have my periodic table out a little bit because you may want to label a couple of things on it. And once you have those things ready, let's go. Okay, so starting off with the history of the table, this diagram you see on the right is one of the first periodic tables that existed. The initial, what we call modern accepted periodic table, was developed by a Russian chemist named Dmitry Mendeleev. And the way that he made this table was he wrote out all of the known properties of every element that was available onto a note card and then started sorting those note cards. And what he noticed was that every 8 or so elements, the properties on those elements kept repeating. Right? So for example, lithium is a soft silvery metal. It reacts with water, it forms hydrogen gas. And then you go through sodium, soft silvery metal, reacts with water to form hydrogen gas. Go through some more elements, potassium does the same exact thing. So whenever you got these repeating properties, what he did was he made a new row or new column on the table. Right? So he also found out when doing this is that for the most part, this also organized the elements by increasing mass. Not always perfect. There are some issues with this. That's why I said mostly. But it's pretty good for what it does, especially for an early table. One of the key things behind Mendeleev's table, and I'll actually note it here, is if you see like these spaces right here. These spaces right here have question marks, right? They have masses, but question marks. The reason why is because the properties of arsenic didn't match the properties of silicon very well or aluminum, but they did match up very well with the properties of phosphorus. So he put arsenic in with phosphorus and then said, yeah, these two spots right here, there's probably something that exists. We just haven't discovered it yet. I'm going to leave these spaces blank for when they wind up being discovered. And what he actually found out was that these were the elements gallium, Ga, and germanium, Ge, that actually slotted perfectly into the table there. Right, so this was the first draft of the periodic table. Very good for what it did, not perfect. Now, also keep in mind, this was done at a time before we knew that the nucleus even existed. Right, so that's the kind of level of information that he was working with. Now, if we move forward into the early 1900s, we have the discovery of subatomic particles, so we know that protons exist. So what they then started doing was, instead of organizing by increasing mass, they organized by the increasing number of protons. Right? So doing this by atomic number fixed every issue that Mendeleev's periodic table had. Right? So all those things where it didn't belong here, I better move it over, all of that got fixed. The modern table is organized into rows, which we call periods. And what the period does is, if you remember your Bohr diagram, they tell you how many energy shells out the outermost electrons are, right? So hydrogen's in the first energy shell, lithium's outermost electrons are in the second, potassium's are in the fourth. There are also columns that are called groups. They're sometimes referred to as families. Those are numbered 1 through 18 on the modern table. If you look up old tables, you'll have like 1 through 8A and then 1 through 8B. We've ditched that decades ago, but you may see it occasionally. We work 1 to 18. The key thing about these groups, so these columns, everything in the same column has very similar chemical and physical properties, right? So just like I said in the previous slide, lithium, sodium, potassium, all of them are soft, all of them are silver, all of them react with water to produce hydrogen gas, right? And they're all in the same column. So this is the modern periodic table. It's the one that you got during the first couple of days of school. Again, if you haven't printed out the color version, I highly recommend you print out the color version so you have access to all the wealth of information that this gives you, right? Because the color version of the periodic table gives you a lot of information the other one doesn't. So the important things that you get from this version of the table: if you look at the color of the element symbol, it will tell you what state that element is at room temperature. Boron, carbon, aluminum, silicon at room temperature are all solids, so they are black. Nitrogen, oxygen, fluorine, chlorine are all gases. They are all red. Bromine and mercury are liquid at room temperature, so they are blue. Right? So that's what that's one thing it can tell you. Another thing it can tell you is you see this red line right here. It may look like a gray staircase line on the black and white periodic tables. This line right here is the difference between metals and nonmetals. Everything to the lower left of that line is a metal. Everything to the upper right of that line is a nonmetal. And the elements that border, right? So the elements boron, silicon, germanium, etc., the ones here in the darker blue color, those are what are called metalloids, right? Because they border the difference between metal and nonmetal. So this version gives you a lot more things to work with. It gives you the name of the element, its atomic number up here, its symbol, its average atomic mass, correctly calculated for the data at the time. It also gives you a value called electronegativity. We'll get into that when we talk about periodic trends, and a lot more when we get into bonding. And here, it also tells you the names of the different groups of elements, right? So anything in green is a noble gas. Yellow is what's called a halogen. So if you've heard of like halogen bulbs. Group 1 are what are called the alkali metals. Group 2 are the alkaline earth metals. Transition metals in the center of the table. Right, so there's a lot of information that you can get just by looking at this version of the periodic table. The last thing I want to go over in this set of notes are the properties of some of these elements. Right, so we're going to work with metals and nonmetals here. Now, the metalloids are kind of in between, right? So metalloids are between metals and nonmetals, so their properties are between the properties of metals and nonmetals. So when you're trying to figure them out, like for example, look at how silicon works, and then you can kind of figure it out from there. So we'll start off with property number 1 of metals. Metals are solid at room temperature except for mercury, all of them. Nonmetals can be a solid, some can be a liquid, some can be a gas, so there's no actual rhyme or reason to it. Metals are good conductors of heat and electricity. Nonmetals don't conduct heat and electricity. They're what we call insulators, right? So things that insulate do not conduct. Metals are malleable. What that means is you can press it into a flat sheet. And in fact, you're going to test the malleability of elements in a lab. Nonmetals are not malleable, but they are brittle. What that means is when you strike them or try to press them down, they'll break apart. Now, metals being malleable also means they're what's called being ductile. Ductile just means we can draw it into a wire, right? So I can take a block of copper and I can either flatten that copper into a sheet and get copper foil, or I can round it off and draw it out into a very long, thin copper wire. The other property of metals is that metals are lustrous, which means that in their normal state, in their non-oxidized state, they tend to be very shiny, right? Copper has this like reddish brown shine to it. Silver, gold, steel, all of that when they're brand new tend to be extremely shiny. So these are the properties of metals and nonmetals. Metalloids, again, sit kind of in the middle. All metalloids are solids. They semiconduct, right? They are brittle. They are not ductile, but they tend to be very lustrous. And metalloids, again, somewhat conduct electricity, right, which makes them very useful in computer chips. And that's pretty much everything we need to use right now for periodic table. I will see you guys in class.